Hey guys, Mr. B here, bringing you a math video. This time, the first time actually making one using the whiteboard. So hopefully I can get through this without making too many mistakes. But you guys know me, so. Alright, so this one is on, as you can see, hopefully, written above here me on my crappy whiteboard. Long division of polynomials. So basically in this video, I'm going to take you through dividing a polynomial by a binomial. I'm going to use a cubic and I'm going to divide it by a binomial. So basically where you might use this to is you probably would use it if you're doing something like, let's see, integral zero theorem or rational roots theorem, and you already knew that you already knew one root of the polynomial and you want to find the other one. So you might use long division to do that. Of course, that's not the best way to do it. Best way to do it would be using synthetic division. So if you're not sure what that is, you should check it. Just search synthetic division on my channel. You find a couple of videos, and that is definitely the best way to do that within the integral zero theorem or rational roots theorem. But anyway, some teachers like you to know this. Another application might be if you were finding the oblique asymptote of a function. You were trying to graph it, of a rational function, and you knew that it had an oblique asymptote and you want to graph it. Usually when that occurs is when you have a polynomial on top in the denominator, or numerator, sorry, 1 power higher than the denominator. So you might have a quadratic on top and then a linear function on the bottom, and then there's a possibility of it being a oblique asymptote as long as the factor didn't cross off. Alright, so let's give this a shot. I'm just going to make this one up off the top of my head, so sometimes these things go great, sometimes they don't. So let's say you have something like this. So here's your cubic. 3x cubed plus 2x squared minus 4x plus 1. So there's your cubic. And we're asked to divide it by, so I'll use my divide by symbol. So I'm actually going to write this like if you were in, what they're in, if you were in, you know, I don't know when you learn this, grade 4, grade 5, long division kind of thing. So I'm going to just take a fairly straight example. I'm going to do 2x plus 1. Alright, so first thing you do is you think about dividing this guy by the first one that we have, x. So you think to yourself, 3x cubed divided by x. Well, what's the answer to that? Well, that is 3x squared. So then what we do from that is we take this guy right here and we multiply it to each one of those. So it goes 3x squared times x and then times 1. So I get, down here I should get the exact same thing for that first one, 3x squared times x is 3x cubed, as I get for that, because you want those to cancel. And then I multiply these two, so that's plus 3x squared. And then what I do is I subtract those. So you have to be really careful about your brackets here. Be really careful. You got to make sure that you put brackets around this, because really that is 3x cubed subtract that guy, which is 0. And it's 2x squared subtract 3x squared, which is negative x squared. So you have to be really, really careful about your brackets. I know I said that a billion times already. Alright, so next thing we do, we can drag that guy down. Minus 4x. Then I think about, got an x here, I think about negative x squared divided by x. Well, of course that's just x, and then we multiply back. So x times x, or negative x times x, negative x squared. And then x, negative x times 1 is negative x. Do my brackets, subtract, write my line. Then what I have here is negative x squared subtract negative x, and of course you should get 0 for that. If you don't, then you made a mistake. Next step, negative 4x subtract negative x, so that's the same thing as plus x, so that becomes negative 3x. Last step, drag down my 1, so I'll call that plus 1. Start back up here, x divided into negative 3x, so I'm just left with negative 3. Then I'll multiply negative 3 times x, negative 3x, negative 3 times 1, negative 3. Draw my line, put my bracket, put my subtraction sign. Then the next step here, so negative 3x, subtract. So I'm subtracting, so that's the same as adding. Subtracting a negative is the same as adding a positive, so that's 0. And then 1 subtract negative 3, so that's just plus 4. So what I have is, this here is what I get when I divide. I do believe you call it your quotient. And here's my remainder. So we'll write R next to it. So some people like some different forms when it comes to this stuff. If we have, you're given this on a test, one of the forms you might see is actually this guy. So let me see if I can write it over here. I'm going to disappear for a second. P of x divided by x minus a. And the p of x being your polynomial, the x minus a being your linear factor that you're dividing by. And I've seen this in some various things, but I'll say q of x, so that's your quotient, plus your remainder divided by your linear factor. So if I was to do this with my question that I have here, and I'm kind of running out of space on this thing, I'll do it over here on the side, I guess. If I were to do this with mine, so my q of x, so first of all, my polynomials here, I'm not going to write that out because I just don't have the space. Actually, well, I can sort of maybe do this, I guess. So 3x cubed plus 2x squared minus x plus 1, all divided by x plus 1. What we're shaking. P of x over x plus P of x over x minus a, or our case x plus 1, and that's equal to, so my q of x, so my quotient, 3x squared minus x minus 3, plus my remainder, so my remainder is 4 over x plus 1. So there it is. So there's two reasons why this is useful. So it's kind of a neat form to write it in, but not only that, if we were doing this on, say, a rational functions problem, if we were going to take the limit of this guy as it went to infinity, we'd actually be able to find our oblique asymptote. So maybe that's a topic for another video, but that's something if you're looking for your oblique asymptote, that might be, this is a useful form for you. But anyway, hope this video helped, guys. Like I say, if you can avoid line division, do it with synthetic division. Check out one of my other videos. For now, thanks for watching, and hopefully this video isn't too crappy because it's the first time using a whiteboard. Alright, see you guys later.